Light sets the absolute speed limit for the entire universe. It races across the cosmos so fast that it easily outruns and escapes almost any gravitational pull it encounters. But there is a specific anomaly out in the deep stretches of space where that rule completely breaks down. A region where gravity becomes so absolute, so overwhelmingly dense, that light itself gets trapped. The boundary of this region is called the event horizon. It acts as a one-way threshold in space. If anything crosses that exact line, it can never return. These dark voids aren't random fixtures sitting quietly in the vacuum. They have a very distinct origin story, and it is tied directly to one of the most violent events in the cosmos. To understand exactly how an object this extreme is created, we have to rewind the clock and watch the life and the catastrophic death of a massive star. A massive star begins its life by igniting its core, spending millions of years steadily burning through its massive reserves of nuclear fuel. This diagram highlights a delicate physical equilibrium. Intense burning of nuclear fuel creates massive outward pressure radiating from the star's glowing core. Pushing against this is the star's own gravity. The immense inward pull perfectly matches the outward pressure. That high-stakes tug-of-war between the push of nuclear fuel and the pull of gravity holds perfectly stable for millions of years. Because this entire balancing act depends completely on an inexhaustible resource, there is a strict ticking clock on the star's life. The tipping point arrives the exact moment the star burns through its final reserves of nuclear fuel. With outward pressure suddenly gone, gravity instantly wins the million-year battle, forcing the entire mass inward. The core, once the engine holding the star up, rapidly collapses in on itself under its own weight at unimaginable speeds. This violent structural failure in the center sends a cataclysmic shockwave bouncing back out, blowing the star's outer layers away in a massive supernova explosion. While that brilliant outer shell is completely destroyed and scattered across the galaxy, the real physical extremity is happening in the unseen surviving core. If that remaining core contains enough mass, gravity continues its relentless inward pull, and absolutely nothing in the physics of the universe is strong enough to stop it. The matter compresses down so densely that it mathematically punctures the local fabric of space, officially creating a stellar black hole. This scale comparison chart visualizes where stellar black holes fit into the wider spectrum. We observe 4 distinct categories: stellar, intermediate, supermassive giants found at the centers of galaxies, and much smaller, hypothetical primordial black holes. Regardless of their vast differences in cosmic scale, the underlying physical mechanism remains identical, an overwhelming amount of mass concentrated down into a single inescapable point. Look at the sheer physical contrast of this life cycle. What began as a brilliantly glowing, fuel-burning sun has been reduced to an entirely invisible gravitational trap. It serves as physical proof that over a long enough timeline, gravity is the final, undisputed victor in the universe. People often hear the term and imagine a black hole as an empty void, or some kind of vacuum tearing through space. The physical reality is quite the opposite. It is a highly compressed, tangible object made entirely of the crushed, hyperdense remains of a dead star. When a star of this magnitude dies, it doesn't quietly fade away into the dark. It leaves behind a permanent, inescapable shadow where not even light can survive.